Okay, so let's find the slope of the tangent line at the ordered pair 1, 1 if f of x is equal to x cubed. Okay, so just to get a little visual of what that looks like, you can come over here and just sketch it out. Okay, we know that x cubed looks like this. Give or take a curve or two. Okay, it looks like this, and this is the point in which we want the tangent line. So here's our tangent line at that point, and this is the line that we want to know the tangent of. So we will use our limit process to do that. So again, whenever you find the derivative, we call that f prime of x. And so to find that, we're going to use that limit process where the limit as delta x approaches 0 of f of x plus delta x. And we're using x's here and not c, because we know that this will help us to find the slope at any x value. Then we're going to go back and use that ordered pair to find the slope at this particular x value right here. All right. All right. So what we do with this is to find our derivative. Is f of x plus delta x, means in this function right here, wherever we see an x, we're going to replace it with x plus delta x. So that's going to become x plus delta x to the third power minus f of x itself is x cubed all over delta x. Okay, I'm going to expand this by using the formula that a plus b to the third power is a to the third plus 3a squared b plus 3ab squared plus b to the third. Alright, memorize that, we use it a lot. So f of x is equal to the limit as delta x approaches 0 of x cubed plus 3x squared times delta x plus 3x delta x squared plus delta x cubed minus x cubed all over delta x. So if we do this part right, and we are going to always do it right, then everything that does not have a delta x in it should cancel. Do you see the x cubes there canceling because one's positive and one is negative? And then everything else that's left, you should be able to factor out a delta x that can cancel with this delta x down here. So out of these three terms that are left, I'm going to go ahead and factor out a delta x to get to 3x squared plus 3x delta x plus delta x squared all over delta x. So f prime of x is equal to the limit as delta x approaches 0 of 3x squared plus 3x delta x plus delta x squared. So in order to finish this limit, I'm just going to use direct sub. In the place of these delta x's, I'm going to put 0. So remember, when you use direct sub for the last time, you can drop that limit symbol because now you're actually about to take the limit. So we're going to replace delta x with 0. Simplify all this, that's 0, 0. So what this tells me right here is that my derivative f prime of x is simply 3x squared. So that's your derivative of f of x. All right, but we haven't done everything it asks us to do, okay? Because it asks us to evaluate that slope at 1, 1. All right, so this is your derivative of x cubed. What happens right here with this derivative is it would give us the slope at any point. The problem is asking us for the slope at 1, 1. Well, with the slope at 1, 1, our x value is 1. So that's what we put in the place of x right here, and we just simplify. So what that tells me is that is my slope, that 3 is my slope at 1, 1. Okay, but like I said, you could find the slope at any ordered pair if you wanted to. The slope at, let's say you had -2, 8, -8, okay, then you would just plug in your x value of -2, and that would tell you that the slope at that particular ordered pair is 12. All right, so what the derivative does is it gives you the slope of the tangent line at any point on f of x, depending on the value of x. Okay, all right, let's try another one here. Okay, yeah, I think this is, number 3 here. Okay, so let's find the slope of f of x is equal to, we can do a square root function. Let's do square root of x plus 1. Okay, at the ordered pair 2, 1. Okay, so let's find our derivative by using this limit process. So the limit is delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So we're going to plug in, okay, in the place of this x right here, we're going to plug in x plus delta x. So that's going to be the square root of x plus delta x. That's what went in the place of that x. But to this x, we're adding a 1, so don't forget to add your 1 right there. Minus f of x itself, which is the square root of x plus 1. Okay, and what we're going to do is we're going to rationalize that numerator. I'm going to use these analytical techniques that we learned for limits in order to do this. Okay. Almost made a mistake. There we go. Okay. Let me see here. Alright, so we're going to multiply here. That's going to give us x plus delta x plus 1. And then minus a quantity. Alright, you're not going to just subtract x plus 1. You're subtracting the quantity of x plus 1, which is going to require you to distribute a negative right there. Very common mistake. Students miss that a lot, and then they get totally messed up and they don't know how to fix it. Okay? That's not going to happen to you, though. You're going to know how to make sure you fix it, all right, by doing it right the first time. And then make sure you leave your denominator in factored form. So delta x, and then parentheses, the square root of x plus delta x plus 1, plus the square root of x plus 1. So your derivative here is going to be x minus that x is going to cancel, right? Okay. If you want to write the whole thing over, you can. I would probably try to get to the point where you can not write one of these steps down right here, simply because of the time that you're going to have to take a quiz or a test, because everything is timed. Okay, so right here again, you see everything that does not have a delta x in it is going to cancel. So you're left with delta x over delta x times all this stuff right here. Okay, so that leaves us here with this canceling out. So we have the limit as delta x approaches 0 of 1 over the square root of x plus delta x plus 1 plus the square root of x plus 1. Now we're going to take the limit by direct sub, putting a 0 in the place of delta x here. When we put a 0 right there, that just leaves us with x plus 1. I mean the square root of x plus 1 plus the square root of x plus 1. My little Prissy was barking. Had to pause that. Okay, so here we go. So f prime of x is equal to 1 over 2 of these, so 2 times the square root of x plus 1. So there's your derivative, but then they asked us to evaluate that at 2, 1, to evaluate the slope at 2, 1. So your slope would simply be f prime of 2. You're going to put that 2 in the place of x there. 2 times 2 plus 1. That's going to give me 1 over 2 times the square root of 3. I'm fine with you leaving it like this. If this were multiple choice, it might be rationalized to give you the square root of 3 over 6. Both of these are correct, but you know, if it's a free response question, you're okay to leave it this way. If it's multiple choice, you need to know how to leave it this way. Okay, so that is derivatives, and how to use the limit process to find the derivative or to find the slope of a tangent line.